Welcome to SanfordFlipMath. We are working through PreCalculus, Demana, Waits, Foley, Kennedy's book, and we are, again, deeply in the throes of trigonometry. This is our third installment of graphing sine and cosine functions. These are lots of fun, and by lots of fun, I mean you. Actually, it's really not that big a deal. Once you get comfortable with the shapes of the graphs, you need to be able to just, sketch a graph of sine or cosine, blindfolded upside down, hanging from your toenails. And then after that, you just apply the rules for transformations on it, and it's really not bad. Okay, so just piece by piece, I'm trying to take you through it in an order that makes sense, and then I'm trying to make it as painless as possible. I know sometimes there's just nothing you can do, and it's just going to be painful, and I get that. Okay, so worth noting that again we are in degrees. If you notice the example that we're going to work through, and I'm sorry, but the fractions are just all over the place. So don't sweat it. We will just roll through it. And honestly, the fractions are really not that big a deal. The hardest part will be counting scale, and really the fractions kind of go away in this particular one, and you'll see why in just a minute. All right, so shockingly enough, I'm going to sketch a cosine graph, and again, I'm just going to work with initially I'm going to graph cosine, okay, and then I'm going to adjust the scale to make it so it's not just cosine. So reminder that cosine starts at the top. I'm going to go 8 squares to do a full cycle. Again, you can do 4 squares if you wish. If it starts at the top, it's got to end at the top. I always bracket in my cycle first, my period first. Halfway through, it's got to be on the bottom. Halfway between those, it's at zeros. And I do a little sketchy Rooney here, a little curve, 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 curve. We aren't making perfection here. We're not making a Fabergé egg. We're just like drawing a little sketch here. Okay. Same song, second verse. I'm going to do it again. At the top, at the bottom, I'm at zeros. Okay. Well, I didn't like that. Sorry. It's the joys of doing this electronically. I can just hit undo. Something like that. Again, I'm filling in the same kind of point. So this part of it, honestly, should become completely automatic, completely mechanical. There is no thought process going on here once you've done this a few hundred times. Okay? All right. So now that I'm going to start establishing scale, okay, so now is when I'm going to do the 1/3 that's out front here. Well, 1/3 is on the outside. That's the A. Okay. Now this would be this is cosine. Don't sweat that. It's just a slightly different shape. Okay. But it follows the same pattern. When I do that 1/3, that's my amplitude. Okay. So absolute value of 1/3 is 1/3. Okay. And what that tells me is how I'm going to scale the y-axis. So I'm going to call that 1/3. So 2 squares are 1/3 for this. Okay, so do understand that's just how I'm scaling it. And that's how I'm going to do the scale changes by, you guessed it, changing the scale. I know that's deep, isn't it? Okay, so now I'm going to deal with the 1/4 in front of the x. 1/4 x. And that 1/4, now remember, period is 2 pi over b. Now, again, I know that I'm dealing with the 2 pi version because, again, this is in radians because I have that crazy pi over 2 floating around in there, and it's just part of life. Okay, so the period is going to be 2 pi over 1/4. 2 pi divided by 1/4 is 2 pi times 4, also known as a pi. That fraction just disappeared. I'm so excited. Sorry, just a little too excited. All right, so this is 8 pi. So you can call this cleverly enough 16 pi. That doesn't look much like a 16. Sorry, it's jammed in on the end. There's negative 8 pi. That's plenty of numbering on here for right now. In a minute, we're going to need to do some more. Okay? All right, so what's left? Well, I'm going to answer my domain of range no, I can't answer my range question yet because I have a vertical shift. Sorry. Okay. Well, next up on the list is let's talk through the phase shift, and then we'll talk through the vertical shift. Vertical shift is easy, but there's a little foo-foo thing that's in the middle of it, and you're not going to like that, but it's okay. It's no big deal. All right, phase shift. Phase shift is negative c, or opposite of c, Sorry, my math teacher's tuning in, just yelled at me going, don't say negative. Opposite of C. Okay, so the opposite of negative pi over 2 over B. Well, B is the 1/4. Well, this just looks like fractions in a can. This is just nasty. It's right up there with spam. All right, so negative times a negative, opposite of a negative, positive. So this is going to be pi over 2 times the reciprocal, all of that, 2 pi. Okay, rewind if you so need. The phase shift is 2 pi. Well, what direction is 2 pi? Well, it's positive, so it's going to go to the right. Okay, and the vertical shift is -1, so that's down 1. So quick little note to self. We're going to go right 2 pi. We're going to go down 1. Well, what's 2 pi look like? All right, well, let's do some counting. If this is 8 pi, then half of that would be 4 pi. Half of 4 pi is 2 pi. Aha! So 2 pi is 2 squares. Okay, note to self, 2 squares. And then down 1, well, remember that we're not numbering by ones here. I got 2 squares to get to 1/3. So if I want to go down 1, I actually have to go down 3 of those pairs. I have to go down 6 squares. Who counted this? Who made up this crazy example? Okay, so my phase shift, my left or right shift, my horizontal shift is 2 squares. My vertical shift is down 6 squares. So that's what's going to happen. Every one of these points is going to move right 2 squares and down 6 squares. Okay, so I'm starting here. I'm going to go right 2 and down 1, 2, 3, 4, 5, 6. I'm not going to do that every time. I just want you to see that. I'm going to do it one more time. Okay, I'm going to take this point and I'm going to go right 2, down 1, 2, 3, 4, 5, 6. Okay, I haven't done the bottom one yet. Okay, we'll do, well, all right, I'll do one more. Sorry. 1, 2, 2, 4, 6. Okay, so far what I have is that. Okay, I'm going to move the rest of the points and then I'll come back around and do some sketching here. Okay, now sometimes you can do this relative to what's going on. I'm just, hey, stop it. All right, so I moved 1, 2, 3 squares. So I'm going right 2 squares, 1, 2, down 6, 2, 4, 6. I'm going to go right 2, down 6. I think that's it, isn't it? Well, I can't keep going off the screen and I don't want to write on the recording thing. So, all right, let's just keep this going. So here we go. Make sure I did everything right. It should still look right. All right. So this was kind of where my first cycle started. This is the point that used to be at 0, 1/3. It's now way over here. Okay. Now, I have one last question that I need to answer in my list, I believe. Well, domain is all real numbers. I knew that without even doing anything. Okay, let me do a little highlighting here so we can find this crazy thing. And then we need to answer the range question. Okay. All right, so the range for this thing is going from here to here, or from here to here if you prefer. Okay, so where's the bottom? Well, this was 1/3. 2/3, 3/3. Okay, so this is really -1. 4/3. So I'm going from -4/3. And I already established 1/3, 2/3, so -2/3. So my range is from -4/3 to -2/3. Inclusive. Okay, so there it is. Let me highlight the rest of the answers so you can find them. Okay, and that is it. That is a lot of stuff we just did. And in math class, we don't tend to ask the frequency question. It was mentioned very briefly in the first installment of section 4.4. Frequency is just 1 over the period. So if you're interested, frequency is 1 over 8 pi. And yeah, yes, it could come up, and yes, I might ask you, and I know that'll seem unfair, and so I'm just going to warn you now, I might ask you. Okay? All right, let's do another one. That was about ugly, and that's good. We need practice with ugly. Okay, so let's do another sine version, and this is going to start out, I always tend to start with the graph of the parent function, and then I just adjust the scale to deal with period and amplitude stuff, and then we do any shifting after that. So this is the process. All right, so I guess I should write that down. Start with the parent function, adjust the scale. That's what I do. Now, you know, you might end up with an instructor in college or something that says, "Don't touch that scale. I want you to draw the real one." Okay, well then it's more work, and that's just, you'll have to deal with that. Parent function, adjust the scale, and then I do any shifts after that. Shift is okay. All right, so that's my process that I recommend, and we'll just kind of leave it at that. Okay, so. Oh, come on, group for me, please. Thank you. I don't know where to put that. Tell you what, write it down. There it is. Pause if you need to. All right. Sorry, you didn't need to see all that, but there it is. Okay, sine function normally starts at 0. Full cycle ends at 0. Halfway through, we're at 0 again. Normally, I'm at the top and I'm at the bottom, and you've seen this before. I should have done a cosine like that's upside down, but we'll just roll with what we got here. Quick little note here. It is flipped upside down. Okay, so instead of those guys, sorry, they're going to be here instead. Okay, so there is one cycle, and again, I'm just going to keep going with this. Okay, and it's down on the left this time, which is rare. Or okay, just want to make sure you see all the different. Okay, that's just annoying, but that's life. That's called recording during normal school hours, and that's just how life works. Okay, so what we're looking at right now is a graph of y equals -3. Well, technically it is just negative sine of x, kinda, because there's nothing on here to establish scale, so it isn't even really that right now, but it's kind of close. So all right, let's deal with some issues here. First of all, I want it to be sine of 3x, and so period, as you know, period is 2 pi over 3, because the initial period for sine and cosine is 2 pi, or 360 degrees. So period, well, 2 pi divided by b, so 2 pi over 3. There's nothing equals. That's it. 2 pi over 3. Okay, so this point right here, 2 pi over 3, this is twice that, and this is the negative of that. Okay, all right, so that's period. Amplitude is the absolute value of a. Well, in this case, a is -3, so the value of -3 is 3. Okay, so that means we're going to go up to a height of 3 and down to a height of -3. Okay, now that's before any shifting happens. Okay, and the domain's all real numbers. We already know that. Okay, I don't see, there is no d out here added or subtracted, so the vertical shift is 0, or again, you can say not applicable, or none, or nay, you can't fool me. Okay, range, well, since there's no vertical shift, and vertical shift's about y values, and range is about y values, I can do the range now. So the range is between -3 and 3. Again, if there's a vertical shift, then you have a little bit of work to do. Okay. All right, phase shift is the last thing we need to do, and we need to graph it. And so, shall we? Okay, so phase shift, okay, is opposite of c over b. So the negative of -4, pi over 4, so that's going to be positive pi over 4 divided by 3, also known as pi over 12. Okay, you can play around with reciprocals and figure that out. I've done enough of those, okay, or you can come ask me. Okay, so since it's positive, we're going to shift to the right, And now the big issue here is, and this is the only thing that makes this problem a little more interesting than others, is what the heck is pi over 12 going to look like? Okay, so this is where we need to kind of play with our scale. Okay, so pi over 12. However far pi over 12 is, I got to move that far to the right. Okay, this is where a grid is really going to be useful to you. If you have graph paper, I highly recommend to start using it. This is the time. Okay, all right, so 2 pi over 3 is a whole bunch of squares, 8 of them apparently. Okay, and I'm just going to kind of work this down. So this would be pi over 3, because half of 2 pi over 3 is just going to be pi over 3. Half of pi over 3 is pi over 6. Double the denominator, you've done half. Half of pi over 6 is pi over 12. Ding, 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 ding. Okay, so that's kind of sweet. That makes me so very happy. Okay, so pi over 6, or pi over 12 rather, happens to be 1 square. Okay, so quick little note to self. Pi over 12, 1 square. Again, since it's positive, it's going to the right. Every one of these points that I just graphed on here is going to the right, 1 square. So 1 square, 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 1 square. So, how about them Tigers? Sorry, it's not baseball season. And yeah, that one's not going to go anywhere. Sorry. And here we go. Whoop, that was kind of jacked up, wasn't it? Yeah. Oh, I did it again. I was heading for the red point. That's why. Well, you know what? It's just going to have to be good enough. I'm not going to keep redoing it. Isn't it pretty? I know. I think it's pretty too. All right. So there it is. Except for that little extra hump in his back. So it can be the hunchback. And that's it. We've done everything. That is the bomb. Okay, that makes me so very happy. Okay. Okay, so again, the basic steps were start with the parent function. Now, if you know there's a reflection vertically, then I would go ahead and flip it. If there's a reflection horizontally, I would go ahead and work on the other side and flip it the other way. It's pretty rare for the B number to be negative. But if the B number is negative, it does flip horizontally across the y-axis. So from the left goes to the right goes to the left. So start with a parent function or a version very similar to the parent function. Adjust your scale to what the amplitude and period is. That just makes it easier. I mean, technically, by changing the amplitude, it makes it taller or shorter. It's just much, much easier to deal with these things by looking at this thing, by changing the scale, I guess I should say. Okay. In fact, let's just take, I know I was kind of wrapping up, but things occur to me. So -3 sine of 3x. Let's just go over here for just a second. And apparently I have to turn off the highlighter thingy before I go there because that's good. Okay, smart ink, come wake up, clear ink, and turn off marker. Thank you. All right, cool. So that should work. Okay, so I think it was -3 sine 3x. I don't want to worry about the phase shift right now. All I want to do is compare this, first of all, to sine of x. I really don't want these in this order, though. Okay, so there, I just fixed them, put them in the order I want. It's going to graph sine of x first, and then it's going to graph -3 sine of 3x. So I want you to see what's going on here, and I'm going to do zoom 7, which is zoom trig, so it'll account for whatever units I'm in. All right, so there is regular sine. Notice this is taller and narrower. So kind of hard to see everything that happens. So let me do this. I'm going to do, I just want you to be able to focus on one thing at a time. Okay, so, sorry, I went too far. There it is. Okay, so this is just the 3. This is just the amplitude changing. So this is sine of x, and then here comes 3 sine of x. So notice the 3 makes it taller. Okay, I want to move that 3 now. Okay, I should have done this on the video before this, but I didn't, so sorry. 3x. Should have actually done it probably the first one. All right, so here's sine of x. And then after that, sine of 3x. So notice how the amplitude did not change, but the period did. Notice how if all of this if all of this was one period that was 2 pi, notice how now I have a period and a period and a period. All of that happened in in what used to be 2 pi, so that's now a third of that, so 2 pi over 3. Okay, so let's put that together, put both 3's in. Okay, so now again, this is going to make it taller and narrower. So here's the 3 on the outside, making it taller, and the 3 on the inside, making it narrower. And then we're just going to do one other thing. I'm going to get rid of this. And there it went. Okay, we're almost out of here. Sorry. Okay, so now it's upside down. Okay, so there's always a way to make the videos at least 20 minutes. I'm sorry, I thought I was done at 17. All right, so thanks for watching. Hang in there. This is doable. Next video is not going to be trig graphing for sine and cosine. It's going to be solving trig equations. Different topic. It's related to this, but it won't feel like it. And then after that, we'll go to the other trig functions. So thanks for watching. SanfordFlipMath out.